The most diverse substances are transported and distributed in piping systems every single day. They can include solvents and chemicals, oil and gas, or steam for energy transmission. The fluids flowing through pipes often have completely different properties. Therefore, different principles for their measurement are required. One method is flow measurement, based on the differential pressure principle. Some 300 years ago, Swiss mathematician and physicist Daniel Bernoulli discovered the direct relationship between the pressure and speed of a fluid flowing in a pipe. Italian physicist Giovanni Battista Venturi also performed experiments on flow, and in 1797 he built the first flow meter for closed pipes, known as the Venturi tube. Here is how this measurement method works. Differential pressure flow meters have an artificial restriction integrated into the measuring tube, illustrated here by the example of an orifice plate. Two holes are located in the pipe wall, one before and one after the orifice plate. Two separate tubes connect these holes to a differential pressure sensor, with its two pressure chambers separated by a diaphragm. The tiniest pressure differences in the flowing fluid can be precisely measured. If the fluid is not flowing, the pressure before and after the orifice plate is essentially identical. As soon as the fluid starts to flow, its velocity around the orifice plate increases significantly because of the restriction in the cross-section. At the same time, due to the laws of fluid mechanics, the static pressure at this point decreases. Consequently, different values are detected in the pressure chambers of the sensor, a higher pressure before and a lower pressure after the orifice plate. This pressure difference is a direct measure for the flow velocity, and thus the mass and volume flow in the pipe. The higher the flow velocity, and the resulting drop in pressure around the orifice plate, the greater the differential pressure measured. In numerous industrial applications, the orifice plate covers many needs of flow measurement technology. However, other designs are available for certain measuring tasks to minimize undesired effects, such as excessive pressure loss or abrasion of components due to solids carried in the fluid. This demonstration shows that an abrupt restriction generates severe turbulence in a fluid. Nozzles with a rounded, funnel-like inlet clearly reduce turbulence and thus create less pressure loss. Nozzles are particularly suitable to higher flow velocities or to fluids with abrasive solid particles. Turbulence reduction is even greater with Venturi nozzles. And finally with Venturi tubes, where the restriction is created by longer conical constrictions in the pipe wall. All these designs can be supplied with different restriction diameter sizes, so that the pressure loss and the differential pressure generated can be optimized for the process conditions. Industrial flow measurement using differential pressure has been tried and tested in numerous applications worldwide for about 100 years. With this measuring principle, all liquids, gases, or steam can be measured, even at extremely high process pressures and temperatures. Every differential pressure flow meter manufactured by Endress and Hauser is configured to customer specifications and pre-mounted. For all applications, we have the right solution. Endress and Hauser, your single source supplier for measurement technology.